My name is Craig. I am a senior software engineer at Google. Yes, I would encourage everyone to mute because of background noise. Thank you. I'd like to talk to you today about topics that I wish I had been able to present at the UNESCO conference in December, but 10 minutes did not suffice. So thank you all for making this opportunity to show you some more details about languages and how we can work with, excuse me, I'm trying to do two things at once, how we can work with new languages on the internet. So I would like to just describe that this is a basic technology talk. It does not describe everything about language. I'm not a linguist, I'm a computer person, but these are the basic things that are needed to get languages on the internet using written forms. Now, everybody knows that language is used on the internet in many places, and I'm not going to go through all of these, but we use it to communicate with text messages and email. We also, in many cases, are able now to use speech and even machine translation, at least for some languages. But it's also used for publications of all kinds of things, newspapers, word processing on individual computers. Social media is a huge consumer and source of text, and of course business. But it's also important that native languages can use the internet tools for written text for things like textbooks and all kinds of materials, and give children and adults the ability to learn to read and write in their language using these modern technologies as well. And of course, language is also adaptable to people who may not have traditional reading and writing skills, so using screen readers and real-time captioning, and of course, many other things. I'd like to talk about the basics for using language online, and I'm going to focus on written language. The very first thing is that it's important to have some agreement on the symbols that are used in a language. There are many different scripts in the world, many of them already in standard form. But if a language is going to be used and shared, of course, people need to agree on what the symbols are and what they mean. It is not necessary for a language to have its own script. It is also not necessary for a language to use just one script. There are many examples of languages that use multiple scripts. For example, Serbian, a language of Europe. About half the people in Serbia use the Latin script, the other half use the Cyrillic script. And there are many other cases of this. Once we have an agreement on what the characters that are going to be used for the language are, then we can talk about how it's actually going to be displayed. The font that is used to display a particular character or a set of characters shows the exact shape of the characters. In many cases, where people have only had handwritten characters or characters written with only one form, perhaps from metal type, that they've become accustomed to over many years, the people using that language may think that there is only one exact shape for these languages. But with modern font technology, it's possible to have variations in shape, and this actually adds to the richness of written forms. There are input tools. It's wonderful if people can read the language on their machines, their mobile devices, but people, of course, are creative and want to communicate and send their own messages. And so we need ways of creating and storing, editing, transmitting text in digital form, both between people directly and between people and applications online, such as search, word processing, social media, and many, many more. And of course, applications need to be able to use the tools above naturally for their language and writing systems. Most applications, of course, have been adapted over time for the major writing systems, major languages that are used online. But many of them can fairly easily start using writing systems that are not used yet, but with the standard tools, they, in many cases, will immediately adapt to that and make it possible for people to read and write and work in tools such as text processing applications with no changes to their computing systems. It's important to understand the concept of an encoding. An encoding is simply the idea that there is a number that is going to be associated with a character. One of the early examples of an encoding system was ASCII. ASCII stands for American Standard Code for Information Interchange, and it's important to note that the American part is there because it is restricted to only 128 characters. And this is a small sample of it. The codes are often given in numeric form in either decimal or hexadecimal, base 16, or base 8, or even another HTML code. But all of these things have the same numeric form, a pattern of bits to represent a character. So yes, a blank space has a decimal form of 32. The character capital A has a decimal form of 65. And computer people often write these in hexadecimal form for various reasons. They're more compact that way, and they match the bit patterns more easily. That's not important for this discussion, but it is important to understand that to have a writing system used by a computer, it needs to have an encoding that has one character to each number, and that this be defined in some way. Now, Unicode is a system that is the most complete encoding. There are actually many, many encodings that have been developed over the years, for some for specific languages and writing systems such as Chinese, others such as the ISO 8859 series that actually has multiple parts. That one covers much of Western European languages, another part adds Turkish, and another piece adds Icelandic, Arabic, and Hebrew are also supported in that. But each of those is a fairly small set of characters. But in the early 1990s, three men in the Silicon Valley area here decided that this was very confusing. To have multiple encodings meant that an application would have to not only specify what the characters were, but what the interpretation of the characters were. One set of codes would not be consistent with another set of codes. So they decided that they would build something called Unicode. And over the years, Unicode has become the dominant and most complete encoding system available. And remember, an encoding system is just saying each character has a number, and the characters are unique. They do not overlap. There are many, many code points now. A code point is another way of saying a particular character. There are also including emojis, and that number is growing. Right now, it covers over 150 scripts, most of the modern scripts that are used fairly widely now, but not all of them yet, and many historic writing systems. And there is support for most written languages at this point. The important thing about Unicode is that it's supported by all computer and phone vendors now. Almost every application, every device you buy can use Unicode. And that's extremely important. And not only is it convenient, but it's essential for computers and phones to work together. It's not a world where any one manufacturer builds everything for the internet, of course. It's also important to note that the Unicode Standard allows growth and change. People are adding new scripts and characters every year, and proposals are made, accepted after a review process, and a lot of work with the people who use these writing systems to put them into the Unicode Standard in a form that will work and be consistent and compatible with existing, but also allow people to use their characters and writing systems as they need. And if you want to learn more about it, there's a link under there. Unicode.org has lots of information about this. So one can think about Unicode as saying it's a unified, universal system for a unique code for each and every character. Another important aspect of Unicode is that the codes do not overlap. So the codes for the Latin characters comprise a block that contain the basic Latin A through Z, which are used in English, but also include the characters of Scandinavia as separate characters in many cases. They include characters that are used to write Turkish and African languages and many other languages that have variant forms. Each of these codes, or each of the characters, has either a unique code or a shape that can be put together with a combination of codes. For example, the basic A character can have a combining acute accent or grave accent, or perhaps multiple diacritic marks added to it, so that the variations in each writing system can be used. The fact that the codes do not overlap means that it's possible to write multilingual documents, and the document doesn't have to have a special flag in that document saying that it's switching to a different encoding system between different sections. One just merely needs to have the characters in there and apply the appropriate font, and the document can indeed represent any written language that's already available. And because tech companies generally support Unicode, that means that the new scripts and new scripts that are being added to the Unicode Standard over time will become available on almost all the devices that are available out there in the world, including mobile. It doesn't happen immediately, but that support is built into most systems, and when fonts become available, then people start getting the capability of using their writing systems on mobile devices as they are released by vendors. Another important aspect of Unicode is that it isn't just a list of characters and numbers associated with them. Each character, each writing system has properties that are defined for it. For example, the Arabic block has a property which indicates the direction of the flow of the text. So Arabic, Hebrew, and many other writing systems indicate that they are right to left in their direction. Others indicate left to right, and in some cases, vertical text is indicated as one of the directions supported. Each character has a type. Some basic categories are letters and punctuation and digits and space. These are important for advanced word processing, such as where to break between words, where to break between lines. How do you identify what the words are in something that needs to be understood by an application, such as a search engine, that needs to consider the properties of the words in more detail than just a list of the individual characters. And another important aspect of Unicode is that the shape of the characters is roughly given by the Unicode Standard in a representative form, but font creators can build fonts that will show these characters in many, many different ways. Those of us who use writing systems that are widely available and have been used in print and computers for many years are quite familiar with the concept that, for example, the letter A has many different forms, as shown in the bottom, and we can read them because we're used to that. When a character set is encoded in Unicode, font developers, either professionals or amateurs, can build their own shapes for each of these characters, and that allows great creativity and has given us the richness of printed text that's available online and in print. Now, I'm one of the people who actually learned to type on a manual typewriter. My class was not exactly on the typewriter this old, but I learned to type. I was the only boy in my typing class back in that time, which indicates that the idea of typing was that it was going to be for secretaries or maybe the occasional college student. A typewriter is a very straightforward technology in some ways because there is a direct connection between the physical key someone types and the type bar that moves when one types that, and it produces one printed character. And that's not exactly true, actually. In this particular case, one can see that on each element of the type bar, there are actually two different characters. This is actually a more advanced machine than the first typewriters. The first typewriters had one key per type bar with only one character on each type bar. this one actually has the possibility of a shift. And so the idea of a advanced typewriter that would have one key with multiple possible outputs, and perhaps using a modifier like the shift key in this case to produce more than one output, became important pretty early in the development of typewriting. And in fact, that's been extended. Manual typewriters, developed the idea of having backspaces to do overstriking, or particular keys that would prevent the advancement of it, and even special ribbons for things like typing in red or in a different color, or maybe even to erase by typing the character again with a whiteout ribbon. So many of us are familiar with these things. Young people may not know what a typewriter is, but the important thing there is that there was a physical connection between the key or keys that were typed and the output. This is not exactly what happens in computers and mobile devices. Now, of course, people have physical keyboards. Here's an example of a keyboard that is sold in French-speaking areas. And there are differences between this and the keyboard that I'm using on my computer right now. This is called the Azerty layout, and that's because it's Azerty in that top row of letters. This arrangement is not exactly the same as the QWERTY keyboard used in many English-speaking areas. But the important thing is that it's possible to build different physical keyboards. And these different physical keyboards facilitate the use of these languages, and in languages where there are many people who speak the language and there's a good market for the language, and there are standard layouts that have been defined, it may be feasible to build and buy such computer keyboards. But underneath, it's really important to note that computer keyboards are fundamentally different than mechanical keyboards, because there isn't a physical connection between the key that is struck and the character that's produced. Actually, a computer keyboard is a general device that has multiple little switches, and when a switch or multiple switches are touched, they produce a series of information that is interpreted by a computer program. So if I touch the A key on my computer right here, it produces a key code which indicates what key has been output. And there are standards which can be used by computers or by computer software to determine which particular key has what code. In this case, C01 is the leftmost key on that third row up from the bottom, but also the information about which shift, control, alt, function, and other modifiers might have been touched at the same time is recorded, and information about whether the key was going down, or the key was being held, or the key was rising is sent to a computer program. There is a program in every computer that has text input, which we can call a keyboard driver program. And a keyboard driver simply says, look up the character that is based upon the information coming in, the key code, the modifiers, and so on, and look up what physical code, what encoding value should come out of that to be sent to the application program. So computer input has an intermediate step of doing this lookup from the physical information about the place on the keyboard to the actual character that should be produced. In this case, it produces the character uppercase A, which has the Unicode value 0041, and often people put U+ in front of it to indicate that that's the Unicode point. Then the application, of course, accepts the character, inserts it at the right place, applies whatever styling and size and font information, color of text, and so on, and then the display is updated to present the character. And of course, this is happening hundreds of times every minute when people are typing rapidly. So the connection between the keyboard and what you see on the screen, what the application sees, I should say, is intermediated by software. So one of the groups I worked with first that was outside the large languages is the Cherokee language. I happened to run into people from the Cherokee Nation, and they mentioned, oh, we need to get our language working with Google. And over several years, we developed a lot of things with them. It turns out that the Cherokee folks had already done the hard work of getting their syllabary, their writing system, into the Unicode Standard. So their 84, 85 characters at that time were defined, each with a specific code. To build a table that allows Cherokee output from a normal keyboard is quite straightforward. People build a table such as this in this white area, which basically says, given the key code with the particular modifiers, output the Cherokee character codes. And these particular ones are starting with AB, and the whole range of the Cherokee characters is then available based upon the keys that one is typing. Because there are over 80 characters for typical typing in Cherokee, one would have to use both the standard layer and the shift layer. Cherokee also added uppercase and lowercase, and so they actually have 170 some characters. And this means that they need to use Alt and Shift as modifiers if they want to type in the basic way as well. But the idea is exactly the same as any other language. The intermediate program, the keyboard driver says, tell me what character I should output based upon a table. And that table produces the Cherokee code, which goes to the application. And through a Cherokee font, it produces a shape like this one at the lower right. And the key thing here is that this table can be modified. This table can be modified by the operating system, but individuals and other companies and different organizations can write their own input to the keyboard driver program. So no physical keyboard is required. It's possible to do this with on-screen tools. For example, HTML, the language that defines most websites these days, can basically detect each and every key press that is done when someone has the focus in an input window, and that lookup can be done there. So it's possible to build a French keyboard. Even though the physical keyboard is English, in my case, I can type in French with all the characters needed for that language because the HTML has this table in there that is transforming the characters. And it's not, of course, limited to Latin characters. Any writing system can be represented by these keys. So in this case, if I'm in a HTML page and typing, both by clicking on a screen, but also by actually using the physical keyboard, I can very quickly switch between languages and type them. The only problem with this is I have to remember which key goes where. And for my French typing, most of my French typing forgets where the M key is, but that's a matter of my brain, not a problem with the computer. Mobile devices are even more general. People sometimes call these soft keyboards. And with a mobile device, every area of the screen is sensitive, so that a keyboard can be defined by a particular region of the screen, and each one of those little areas is associated with a code, and that code again can be looked up in a table. So there are two parts. There is a keycaps table, which basically defines what symbols appear on each of the boxes that are shown in a virtual keyboard. And multiple layers can be defined, and they shift dynamically. So the actual appearance of it changes, which of course physical keyboards generally do not do. There's also the option of having a long press of a key, which can bring up other options, because basically showing a small menu. And so for languages with small sets of characters, these layers on a mobile device can provide everything that's needed for typing the language with just a few layers. For more complicated languages with many characters, such as Chinese, Japanese, and others with a very large repertoire, Korean as well. The inputs can be used in a different way, not by just looking up in a small table what key corresponds to what character, but in a way that allows people to give hints about what character is being requested. The program can give multiple possibilities, and then a person uses or chooses one of those characters. And this is the way Chinese, for example, is generally written. And people very quickly get to the point where they are very skilled at giving the characteristics of a set of keys and then picking the one. So it's more like a search method in the sense that it's generating a set of possibilities that one chooses to put the characters in. So these keyboards are just special applications that can be built by anyone with the tech skills to build a application for a mobile device. And many of them are already available from online stores. The App Store and the Play Store for iOS and for Android have many that people have built. Of course, with these things, it's also possible to use an area of the screen for showing possible spell corrections and predictive text options. And these are allowing people to type more rapidly by giving parts of the words. But of course, spell checking and predictive text use have many possibilities for people touching the wrong key, and amusing spell corrections are well known as internet memes. In particular, it's possible to use a general keyboard developing tool, and there's something called Keyman, which is now available from SIL as a free tool to be used to create new keyboard layouts and deliver them to users. And Keyman has two parts: the developer, where one defines what the output is for each key, and also rules that can be used to say, oh, these two keys have been typed in a row, maybe they need to be reordered, or those two keys define a new special output. Keyman also has a part that is installed on each person's computer to implement the keyboard that has been developed. So Android, iOS, Windows, Macintosh, Linux, almost every major operating system and mobile device has the ability to run Keyman. So Keyman Developer, this free tool, is one thing that many people are using now to develop their own keyboards. Of course, it's also important to understand that a keyboard isn't just one, or is a particular keyboard isn't the only way of typing a language. Even in English, there are multiple keyboard layouts that have been developed, each of which has its advantages and disadvantages. The QWERTY layout is well known and implemented almost everywhere, but many people say that the Dvorak keyboard is faster and better. And so people can choose more than one layout to be used for their particular language and let people use those layouts which best suit their needs and feel best for them. Here's an example of a JavaScript keyboard that's built within an HTML program, a little test program that I built, and it's for the Chakma language. The things that are required here are to define the positions, to show them on the screen, and then to have that program which intercepts what event happens on the keyboard, in other words, which piece of the keyboard is being touched, and turn that into the characters. And then with the Chakma layout, with the Chakma font being used in the output window, it feels to the person typing Chakma that she or he is actually using a Chakma specific keyboard, because in some sense they are. Now, it isn't necessary, but it's often the case that an on-screen layout tells people where the characters are. And this is useful for people who are learning how to use the keyboard, but experienced people may not even need the virtual keyboard. And so some systems allow you to select a keyboard and then optionally show the layout or not. There's a system called Google Input Tools, for example, which supports over 100 different keyboard layouts and languages in exactly this form, and makes it possible for those to be used in many environments online. We've talked about the keyboards and how you specify what the keys mean, but a critical thing is that there has to be something that tells us what the shape of each character is. In a keyboard, in a computer system, there's the concept of a font. A font is simply, again, sort of a table that says, given a particular code, give me a shape. Now, many of us have seen and continue to see places online where instead of a character that we expect, perhaps something with an accent or an umlaut or some combination that may not be expected in English, I get either an empty box or something indicating that the character isn't understood by my web browser. That's in computerese called tofu, and tofu is used by computer people to say it's a little white box with no flavor. And so tofu means basically the character is not understood. The computer system doesn't know how to display it. Typically that happens when there's a character, but one doesn't have a font for that. You can easily find this in Wikipedia, for example. If you use Wikipedia and you go to the definition of a language, such as the Sora language, and look at the Sora characters I just did a few minutes ago, and I see a lot of little white boxes because my particular machine that I'm using right now doesn't have a font for those characters. Operating systems provide many fonts, Windows and Macintosh, for example, but the fonts are not necessarily installed on every machine. Google and other companies have committed to building fonts for most of the new writing systems that are being added to the Unicode standard. So there's this whole series of no-to fonts, and that stands for no tofu. And Google's no-to fonts are available in almost every modern language. I'm sorry, for almost every modern language now, and they are updated as Unicode adds new writing systems. And these are available for download, and many fonts are also available publicly online, some for free, others for purchase. And the fonts can easily be installed on most desktop and laptop devices. But it's really important to note that it isn't always the case. And this is my favorite little icon here of a mug that demonstrates that Unicode isn't perfect because Unicode depends upon a number of things, including fonts being available. Here's an example of a language and writing system that you may not know. It's called the Wancho script. And Wancho has the Unicode Standard with a page that shows the shape of each character. For example, this one, 1E2C1, has this particular shape for the character. And a keyboard can be made with those characters on it. And a Unicode font may exist, but the shape of the character may be slightly different than that in the Unicode Standard. The Unicode Standard is just a representative shape, but the particular Unicode font here produces that shape on my display by a function very similar to the idea of the keyboard. Given a character and a font, the character code is used to look up the shape, the strokes needed to draw the character, that those are used by the application program to display the character. People can develop their own fonts. There are commercial sources, of course, and all of us know about many different fonts that are available, built into any device you might buy. Also, many applications online offer a set of fonts that they provide. Many of these are available for free, but sometimes people want to have specialized fonts, and they do, of course, have cost in some cases because fonts are expensive to develop. There are university projects that develop fonts, commercial programs, and people often develop fonts to build their own distinctive style for their organization. But it's also possible to build your own font. For example, there's a free application that works on Windows called FontForge, which can be used to take an existing font, make changes to it, or create a new font from scratch. And other tools are available, some of them for free, others for cost. And of course, the more sophisticated tools often come with some cost. But the important thing is that a font is simply the idea of taking a code and describing the shape for it. And the shape is usually defined with some sort of shape editing tool. In this case, the letter K is defined very easily with a series of straight lines, but curves and other shapes can be used by these font programs as well. And then the font also has descriptive information, such as the range of the characters set and other meta information about this. Now, this is all well and good when you have a standardized writing system. And Debbie Anderson gave a presentation several weeks ago about the process of the Unicode standardization, which is really, really important. But many scripts have been used before standardization. And without standardization, what does a person do? Well, very simply, it's possible to take an existing font, such as Helvetica or Times Roman or other font that has characters defined in the ASCII range, A through Z, and digits and so on, and create a custom font. In other words, take that font and modify the glyphs, the shapes of each one, to custom shapes that are needed for the language. And then apply that font. I call this a hacked font because someone has actually gone in and changed it and saved it as a new version. And this hacked font basically takes an existing code, like the character for 0, and may change its shape to some other character needed in a language. Then this font can be shared with all the users of it on their computers, and so people can do desktop publishing, share files, even create web pages, as long as that font is available on the devices that people will use to view that text. And it works fine. It works great. People can set the custom font in applications and then type within that font. Input is easily supported because it's just from the point of view of the application, the characters that are normally typed on that keyboard, in this case, A through Z. And so the output works beautifully for viewing on the screen and for printing when the font is applied appropriately to those characters. However, using a font hack or an encoding font has some difficulties. First of all, while people can share the font among themselves using their own computers, they can't install, in general, those fonts on their mobile devices. They can't install the font on the web. They can't tell big applications, use my font. And so text processing programs such as search and other applications see the characters as simply A through Z. Things like line breaking, things like understanding what the words actually are, and so on, don't work. So font encodings have some limitations, and they can't output the characters without the font. Also, there are no character properties defined in such a case. So it's a useful tool, it's a useful method, but it has its limitations, especially in the internet era. So here's an example of an encoded font, and these numbers in this table are the numbers for the ASCII or Unicode digits 0 through 9, but the font has changed the shapes of these characters. They actually do mean 0 through 9 plus this colon-like character, but all these other shapes are overwritten on the basic A through Z and digits area. When people use this font, it works just great, but this can't be used online because that font isn't understood by the world's computer systems. It isn't understood by everybody's mobile device. So this is a motivation to standardize. And after Unicode standardization, then characters can be made available in everybody's devices, and they depend on the font, they depend on an input method, and those things being installed on the particular devices. Of course, in the last 10, actually 13 years, since smartphones really became available to the whole world, everyone wants to use their languages on mobile devices. And this, of course, depends upon the font and a keyboard being installed. The biggest limitation is that it isn't possible in general to add fonts to many mobile devices. It can be done by specialized procedures done by experts, but it's also possible to do bad damage to one's cell phone if one tries to break into the cell phone system without a lot of knowledge. So even though tech companies and others can build Unicode fonts, putting them in the mobile device is tricky and sometimes very, very difficult. So for mobile devices, it's possible to use any of these writing systems once the font is available in the device and someone has built a keyboard for it. And just like the keyboards I was showing you earlier, people can build keyboards using Keyman and other tools to use almost any language. For example, the Baman characters are defined in Unicode, and on my device, which I have at hand, the Baman characters can be typed with this application, which was built by Google in its Gboard series. Gboard happens to have over 950 different keyboards available for many languages right now. Many people don't even know that their languages are already supported by Gboard, but these are available. And this takes advantage of the Unicode standardization. It's also important to note, though, that standardizing doesn't undo the work that people have done in creating documents using font encodings, font hacks. All of these documents will still work on desktop and laptop machines, but they won't be in Unicode and they won't be usable online. So once a community has done the very hard work of standardizing in Unicode and has worked to develop fonts and input methods, keyboards, then it may be necessary to start the transition to Unicode for everyone. And this is not obvious. People may get a new device that might have the Unicode font in their system, but they may not know how to install a keyboard. And so when community leaders are working on getting people to use their languages, they should make a plan for the new technology, the introduction of it. And I believe that it's important to design training and ongoing support for people learning to use Unicode. If they've already learned how to use an encoded font, they will need to learn how to use their old documents and possibly turn them into Unicode documents for them to share. It doesn't happen automatically. And this conversion may need technical help. For using newly introduced Unicode scripts on mobile devices, this is one of the most difficult parts, not technically difficult, but difficult emotionally, because when a Unicode standard happens for a particular writing system, as it did for the ADLAM writing system in 2017, I believe, my friends who were actually the inventors of the ADLAM writing system were asking me, well, when can we use this on every device in Africa and all of our Fulfulde speaking people who want to use ADLAM? And I said, well, it's going to take some time. There is no requirement that every device support all Unicode fonts immediately. And so this often takes a new release of the operating system for a mobile device to have the font in there at all. And people will generally not build keyboards for a device until the fonts are available. And in some cases, the updates to a particular mobile device may not be available into the new release of the operating system. So older devices may not be able to ever get the Unicode font supported directly by the manufacturer, or the particular manufacturer may decide, oh, this is not important. In the case of Cherokee, for example, in early smartphones, where memory was at a premium, some vendors said, Cherokee, who needs that? Very few users, will just leave it out of our particular build for our particular device. And it required the Cherokee Nation to actually demand that phone vendors include the Cherokee font for any that were sold in their community. Now, Cherokee is a small set of characters compared to many others, and so almost every device has Cherokee font on it right now. But it isn't obvious that every new font will be available in every new device, and patience is required, as well as perhaps some communication with tech companies to tell how important it is. Just a few notes on converting pre-Unicode data. When a community has a tradition of writing and has been using non-Unicode formats for their data, it's very possible to turn those old texts into Unicode values. And this is facilitated by the fact that when people build the Unicode character sets, they typically include characters for everything that is present in both current writing and usually in historical writing. So the Unicode set of characters is generally very complete. But it requires people to write transition rules to say, oh, this code in my font encoding now corresponds to this Unicode character or characters. And writing the rules to do the transition not only for individual characters, but perhaps to rearrange Unicode values if needed, is necessary to take an old Microsoft Word or an old HTML program and turn it into a Unicode-based set of codes, and then apply the font as appropriate. So converting old data requires first identifying what data is out there in the previous font, running a converter, which has been developed with a technical person, and then saving the old data, and then over time removing the old fonts from the devices so that people will get comfortable using Unicode fonts. It's a transition that takes both technical and personal skills, and probably requires someone from the community, typically a younger person who is comfortable with the technology, to help other members of the community. Web pages are very similar. Existing web pages often use encoded fonts. The Navajo Nation, for example, used a version of Times Roman called Times Roman Navajo, in which the digits were reused to do accented characters and characters with a hook underneath. Times Roman Navajo text appears just fine if one applies that particular font, but Google search can't find Navajo text because Google search, like many other search engines, does not actually search for strings of digits because it isn't very effective to use that in search. So Navajo text that is encoded that way can't be indexed properly for advanced tools. So it's very useful to, again, convert these web pages into Unicode. So in conclusion, I propose that any written language can be used with computers these days. It isn't necessarily trivial, but it requires the three basic steps of standardizing the Unicode form of the script. Working through that standardization process then requires fonts that are available publicly and on all the devices, and that someone has created the input tools for it. It doesn't require the big companies to do all this work for you, but coordinating with them may be very helpful. And because most every computer and mobile device now use Unicode as their basic way of dealing with text, new scripts can be added even if the computer is not specifically told that the new script is there, because the fonts and keyboards in many cases just work. Becoming fully digital in a written language does take time and patience and technical expertise, but it's worth the effort. And when users can share their language every day, the communities prosper, pride in their language and culture grows, and the world gets to be a better place. So I say, with a word from my Cherokee friends, Wado. Thank you all. I'd be happy to take any questions.
Thank you, Craig. What a wonderful presentation. Thank you.
So I'm going to stop presenting now, or did I already? Yeah, I'm not again.
I have a lot of questions.
Ask away.
Like now I know that Sora's Noto Sora is being worked on. So I want to know when it's going to be released. And the other question is like, do you work with people who are Sora experts or people who like does Google work with Sora people who write the script? So if there are some nuances which are missed, how is that going to be addressed in the Noto font which is going to be released?
The You have several questions there. First of all, um, from your mention earlier this morning, or earlier, is the first mention I've ever heard of the Sora language. So this is all new to me, and that's good. There are thousands of languages in the world. I don't know of all of them. And I did look, and I see that Unicode already supports the Sora script. And so that very big step has already been done. As far as that font being available on existing mobile devices, I haven't checked, but I surely can. One way to do that is for me to simply create some of these characters and send them to myself in an email and see if they appear in my email with the right characters, and that will tell me whether the font's installed on my device or not. The Noto fonts are publicly available, and I can help people download them for use on desktop or laptop. And then the next step of getting them into mobile devices may or may already have happened. It depends when the font was developed, when the standardization process was done.
So my question was like around if there are some characteristics of a letter which is missed, then is it possible to give some sort of feedback to the team so that they change the symbol which is being used in the Noto Sora?
The Noto fonts? Yes, the Noto fonts are open source, and that means that people can find where the fonts are. They can download, but in the website, it's called GitHub, where these fonts are stored. People can also post issues, and those issues are actually looked at by both Google people and other people who have who are passionate about getting these fonts working right. And many times these fonts can be corrected, and then those updates will become available over time in mobile devices. But as I said, installing new fonts on mobile devices is pretty tricky, and sometimes needs to wait a cycle for the device manufacturer to pick up the new form of it. But once the update is done, then people can use it on their laptops and desktops immediately.
Another question I had was that, like, when I look at the Google keyboard, say, which is supported in WhatsApp, it has like a handwriting keyboard. It has like a converter which can convert from, say, English to like my local script, like Odia, or English to Hindi. So these various kinds of keyboard, like, I was particularly interested in the handwriting because I work with AIML tools. I work as a designer for it. So is it possible to work with the team which works on these Google keyboards? And because if that is needed to be done, it needs a lot of data, it needs a lot of handwriting, and for the model to work well. So is it possible to work with the team to work on these keyboards?
I can't speak for the Gboard team specifically. I'm not on that
Okay.
particular team, but I do communicate with them, and the answer is maybe. I surely can connect you with the people there, and we can see if it's possible to support Odia or other writing systems. Google, like any other company, has many things that it would like to do, and we can't do all of them. To a large extent, the Gboard effort that has created 950 different keyboards has completed what it thinks is most of the major languages of the world that it knew about when that project was very active. But we know that languages and the use of language online is changing rapidly, and so it may be possible. So I will be happy to be in contact with you and see if I can connect you with that team.
Okay.
And the other thing that is possible, that's exciting, is that if you have technical contacts, and there are many technical contacts all over the world, especially in India, who know about these things, it doesn't require Google to build this for Android. It doesn't require, there are lots of high school students who know the basics of these things as well. So that's the wonderful thing about open source and the wonderful thing about standards. But of course, I'll be happy to help you investigate what we can do for you.
Thank you.
Can I ask a question? No, actually, it's not a question. It's sort of a comment. We came up with a script in early 2013 with members of the Mehri community in Dhofar in southern Oman.
Mm-hmm.
And then more recently, the Mehri Centre for Studies and Research came up with a competing script, which is far more complicated.
Mm-hmm.
And I spent the weekend feeling rather cross about this. And then I thought, why should I? One of the things that I realise we should be concerned about is forced standardization.
Mm-hmm.
And I think many languages will have many different varieties. And there is a danger of taking the main variety and taking that as the standard. And it's certainly a potential problem among my Mehri community, because there are a relatively large number of speakers. There are probably about 200,000.
Mm-hmm.
For a much smaller community, so within the language group that I work, there is a community which only has 12 speakers. It's much less of a danger there. And at the end of the weekend, I thought, actually, it doesn't really matter as long as people write.
Mm-hmm.
And as long as it's comprehensible, it doesn't really matter.
I agree with you. It doesn't really matter as long as people agree on what writing system to use and use it consistently. And if there is a good case to be made for then doing the hard work of standardizing that and developing the tools and fonts to implement that on devices, there's no reason why many or several different scripts can't be used for any particular language. I was on a call last week about the Gandhi language, which is maybe a language or maybe a language group in India. I don't know that much about it, but there are two scripts being used, Masaram and Gunjala. Both of them are in Unicode Standard. There's it's up to people which one they want to use, and this particular group was talking about Masaram, and a man from SIL has developed a keyboard which can be installed on. It turns out Masaram and Gunjala are both on my phone because they've been available for several years now. Another example, the Sunawar community in Nepal and Sikkim have two writing systems that they use, and Quetzalcoatl, and another one is called Tikamula. And that community of about 30,000 speakers, some use one, some use the other. Neither of them has been in the Unicode Standard yet. And the communities need to decide where they want to put their resources and what ones they'd like to use for education. But because they already have some encoded fonts, they could start using, for example, your ebooks, and with the right font, start generating ebooks in Sunawar in either of those scripts. They won't be available on their mobile devices, but they will be available in other ways. So I agree with you. It isn't so critical that people have just one script for their language. I also want to be cautious. I'm not a linguist. I'm not an expert in languages, but I do want to encourage people to not immediately assume that for their language they need their own writing system. If people want to use their language, they can very easily, in many cases, use an existing writing system and make adaptations for it that may meet their needs. And that smooths the road, then means that the several year-long standardization process does not need to be followed, and the other tools like keyboards can be more easily developed with the fonts that are available
Yeah.
in places right now. So that's a decision for the communities to make, not the standards committees, but the standards committees do make sure that once a community has decided these things, is there evidence for the characters being used, and is there an understanding within the community about what each one means?
Yeah, well, I mean, the script has been adapted from Arabic because people are, if they're literate in Arabic. So that was the easiest thing to do. So it's just a question of the centre adapting more of the Arabic characters than they needed to. But my feeling is that as long as each group or each community is consistent, is internally consistent, then that's the main thing. As long as it's so I can adapt if I see the way in which they've written art and I write art in my group, we write it in a different way, then that's not a problem. It's internal consistency, I think.
Yes, I sit on a committee which meets monthly. It's led by Deborah Anderson at the University of California, Berkeley, and that committee is looking almost every month at proposals for new characters to be added to many different scripts, including Latin, Arabic, and almost every other script, either modifications to existing characters, and they all depend upon evidence that these characters are actually being used. And when people say, oh, I need this new character because we want it, they do require some attribution and evidence that it actually is being used rather than someone thinks it's a good idea going forward. So these and take if I believe Jeanette has a link to Deborah's description of the encoding process for Unicode.
Is Deborah on this call actually?
I don't know.
I've just seen a message from Deb Anderson.
Yeah, that's me. I'm here.
Yes.
Are you the Deborah he's talking about?
Yes, yeah.
Yeah, great.
So Deborah's the expert on that aspect of it. I think Claudio has a hand up.
Yes. Well, first, to congratulate Craig for this very comprehensive presentation on this aspect of what we call the technological iceberg that brings a language to be present in the world, in the digital world. It was excellent. And I have a question and a comment, Craig. I am trying to group the three aspects of the use of symbols in the cyberspace. We have the code, which is this work developed by Unicode to have a bionivocal association among the digital code and the symbol. Very well, number one. Then we have fonts, at times New Roman, all this Arial and all things. And there is a third concept, which is what we see, what the user sees. If I'm not mistaken, it's the glyph. You have italic, you have bold, you have all these different symbols. And these three levels, let's say, require different players because part of this work is done by software. So could you comment a little bit on how the technological local community can help in making available, I would say, fonts and glyphs that are useful for including the local language in the cyberspace. I speak by that because here in Brazil we have around 200 indigenous languages, and there is always a certain difficult thing. This is my question. And my comment is the following. I am going to put the link of a paper that I presented in this UNESCO thing, language technology for all, I think, when I met Jeanette. And this paper is associated to a software that I'm going to put the link also here. And if Jeanette and the colleagues think pertinent, I can make a presentation on this methodology and on the software in the other meeting, okay? But my question is much more on the role of the local technological community to enable the better use of language.
Okay,
the glyphs, you know.
I'm not sure I have a complete answer to that, but focusing on the part about fonts and styles, the development of a new font for a writing system, whether it's a new font for Latin characters or a font for a script which is recently encoded, does require effort and time. And for individuals who know how to do these, who know how to do font development, it may be relatively straightforward to start the process and to get the shapes that a community of users likes and recognizes as their own is a matter of interacting between the font developer and the community. There is the challenge in some cases where a community will say, well, those are the characters we want. For example, there are communities in Assam that use characters from the Myanmar script, but they prefer and actually have a very strong preference that the characters have some stylistic differences, a large prominent dot in many of the consonants, for example, that does not appear in most Burmese script fonts or Myanmar script fonts. And so the community is working to try to figure out how they can deal with fonts, how they can use fonts that represent the characters with this dotted form that other people who use this script do not. For a desktop or laptop computer, it's pretty straightforward to take an existing font and with someone who knows about font development, even an amateur, to modify the shape of the characters and provide an alternative font that can be applied. So the difference between bold-facing and normal face is very similar to what people can do to change the style. That's not terrible, and many people know how to do this even without being font designer professionals. But on a mobile device, of course, there are bigger limitations on what people can choose for their fonts. So even I can't choose a wide variety of fonts to appear upon my mobile device. There are certain system fonts that show Latin characters. I don't get to choose them because there's limited size, there are limited capabilities on a mobile device. So there is an inherent conflict between the particular style and shape of the characters that people expect for their particular use versus what they'll get on a mass-produced commercial device. And that is a conflict that I don't know exactly how to resolve completely. Does that help?
Yes, I used to joke by saying that there are always good ideas to implement with the time and the money from somebody else.
There is not a firm line between a different style of characters and distinct characters. And there are some communities that have styles that are distinct enough, and they make strong arguments that the characters should actually be two different sets of characters in Unicode. And Debbie can fill you in on details there. But I think I saw Sia with his hand up. Is that true? Sia, did you have a comment? Please, okay. I'm happy to continue, but Jeanette, you're the moderator.
Well, it is 20 past the hour, and it's great because we have a really good conversation. So we should be planning 1.5 hours from now on, since, you know, the whole purpose of us meeting on a monthly basis is to have this type of contacts. I just had an email from UNESCO, one of our colleagues there, Christina. She was unable to come to this meeting because of completing meetings, but they're extremely interested in our small group here and how we're developing it. And I feel that, we can get ready for the decade. And this is the, whole purpose of us coming together as a community. The decade that starts in 2022, we have plenty of time to get ready. So we have planned up Janet, Sonny, and Claudio to give more presentations. So we're going to set up a date for early November now, and we'll be able to communicate through email to see who is more able to join. We also have Anna Bellew that said that she will do something in November if she's available, and has created it. Otherwise, we'll ask her to take a step behind for the month after. Anything else we want to discuss now?
I just want to mention that I'm very happy to be in communication with anyone who has further interest in this. So, Jeanette, please feel free to share my email with anyone, and I'll do what I can. Thank you all for being such a good audience.
The invitation a month from now.
Excellent.
Okay.
Thank you.
Thank you.
Okay.
Bye.
Bye. Bye.
Bye.